Finding the equation of a line. In some scientific and engineering applications, we might have obtained the graph of a straight line. The graph might have been produced by plotting data from an experiment, and we might want to calculate its equation. We shall see some applications like this in the final part of this unit. In the following example, we shall see how to find the mathematical equation of a line. Suppose an experiment has been performed and pairs of values x and y have been found and plotted. Suppose the graph looks like this one shown here. Let us see how we can calculate the equation of the line. Because the line is straight, then it will have an equation of the form y equals mx plus c. Recall that c is the value of the vertical intercept. We can read this directly from the graph. The graph cuts the vertical axis at the point marked c, where the y-coordinate is 4. We conclude that the vertical intercept, and hence the value of c, is 4. Therefore, we know the equation must take the form y equals mx plus 4. We must now find m. There are several ways of finding m, some of which are rather too advanced for the material in this course. We shall proceed as follows. We use the fact that the line passes through several known points. We can see some of these on the graph, for example the points labelled A, B and D. Because these points lie on the line, then we know that their x and y coordinates are related to each other through the equation y equals mx plus 4. We say that the coordinates x and y satisfy the equation. For example, the point D has coordinates 1, 7, so that when x equals 1, the value of y is 7. We can substitute or put these values into the equation y equals mx plus 4. To substitute means to replace the letters x and y by the values 1 and 7. Doing this, we find 7 equals m times 1 plus 4, so that 7 equals m plus 4. So m must be the number to which when 4 is added, the result is 7. And that number must therefore be 3. We conclude that m equals 3. The equation of the line is then y equals 3x plus 4. We can check whether this is correct by substituting other known points. For example, using point B, where x equals 3, and substituting x equals 3 into the equation y equals 3x plus 4, we find that y equals 3 times 3 plus 4, which equals 9 plus 4, which equals 13. So if the equation we have calculated is correct, the point 313 must lie on the line. Inspection of point B on the graph allows us to verify or see that this is indeed the case. This example was relatively straightforward because we could easily read from the graph the value of y when x was 1. In turn, this made it straightforward to calculate m. To tackle more general cases, it is necessary to have some knowledge of the solution of equations. We will see an example like this shortly. If you are not familiar with the solution of equations, for now you should be satisfied with obtaining the value of m by educated guesswork and/or trial and error. Now try the following activity for yourself.